Hey everyone, today we'll be having a look at ESP32. The reason I'm using ESP32 is because it's super cheap to get. I just ordered mine from Amazon for just $14.99 and received 2 pieces. So it has a bunch of built-in features. For example, it has around 5 MB of RAM, and then it has also a dedicated chip to control Wi-Fi and Bluetooth. Also had dual CPU to process the information. So I ordered this, and I am preferring this to use for my home control project. Now let's look at the things that we'll have to do to start the smart home control project. We'll first install the Arduino, and then we'll install ESP32 support for Arduino, which is just sort of a build. The company that makes ESP32 has developed a firmware, customized firmware that supports development of the programming using the Arduino kit. We'll also take a look at installing MQTT support on Arduino so that we can talk to services, different services on the internet using this protocol. Now, the reason I'm using this protocol is because it solves a lot of problems like connecting TCP/IP and then other stuff. And then we'll use this to make something that will act in between the IFTT and hardware board. So the IFTT, right? This is essentially a if this then that kind of a service. When certain action happens, it will trigger something else to do. So in this case, we'll hook it up with Google account. And when we try to say turn LED on to Google Assistant, then the action would be to send OK or on to Adafruit. So essentially in IFTT, we'll configure the service to turn already on signal from Google Assistant and then send just on string to Adafruit, which in turn talks to our ESP32 board, which was developed on Arduino based program. All right, so let's get right into it. All right, so first step is to install Arduino. So let's head over to Arduino's official website. Under software, we should see download section, and under that select multiple options to download it with. I am using Windows right now, so I'll just head over to Windows and then download an installable file. It also supports multiple architectures, so if you have Mac OS, then you'll use this link, and if you have Linux, then you'll use this link. I'm just gonna install it first. Once that is started, we are going to take a look at how we can install the support for Arduino and ESP32. So all you gotta do is ESP32 Arduino, and that should take you to the official GitHub repo. So they have this firmware that is developed for ESP32 by ExpressIF that makes ESP32 chip. And now if we head over to the README file, it has contents that has installation instructions. There are two ways to install the firmware. One is pre-compiled firmware that comes from the ExpressIF company, and then other is by yourself. And I would not recommend using any of this method unless you know what you're doing. So let's head over to the basic and let's install whatever they have. So these guys continuously update them firmware. So we'll just use stable link to install our firmware. By now this installation is done, so I'm gonna just close this and open the Arduino. I already had connected the ESP32 chips that I received from Amazon just today, but I'll do this again so that it's explained to everyone doing it for the first time. Head over to the file and then preferences, and inside preferences you can just add this link here under additional boards managers URL. So basically we're telling Arduino that we have a custom board apart from Arduino, and it has like all the additional board managers links under here, and it should be able to download the setting files and the configuration files and the firmware files. And once that is added, press OK. We'll go back to tools, and then under board we need to install the ESP32. Now it is seen here, but it won't be seen for you, so you'll have to go to boards manager, let it download everything, and once it's downloaded the index files, you should just see search for ESP32, and that should give you latest, whatever the latest version is, and then click on the install. Since I have already installed that, I won't do this again. And once you close this, you can go back to the board, and then you should see this ESP32 Arduino, and under here you will see a lot of ESP32 boards. You can see the board type here. It's the dev kit which should be here, development board. So we'll just select that board in the boards, and then ESP32 Arduino, and then the module, and that should allow us to upload anything that is related to ESP32. One more thing to notice is you should see this ESP32 demo module on COM3 once you connect the ESP32 board to your laptop. I'm just gonna do the connection. Once the ESP32 is connected, you should be able to see it under serial monitor. Before that, you'll have to choose the port. Generally, if you don't have any devices connected, and you should see only one COM3 port. If you have multiple COM3, you can try one by one and check if it shows anything in the serial monitor, and make sure the LED on the ESP32 is on, the red LED. Make sure that everything is installed correctly. So to do that, we can do an example installation of Blink using the Blink program. You can find that under File, Examples, and then Basics, and then Blink. You should be able to see a few things. The LED built in, which is not defined here. So if you try to compile, you should get an error. For us, it is on pin number 2. So we can define it here using this syntax. It has defined LED built in 2, and then check if it verifies. Now once this compilation is done, you can head over to upload button and just click on upload. And now if you look at your ESP32 chip, you should see a light blinking, the green light blinking, which I'll attach the video. Now once this test is complete, you can be sure that this custom board installation is done. So let's see what else is remaining. Now we also need the MQTT support. So it is just like the way we installed ESP32. Go under Sketch, and you should see Include Libraries, and then under Include Libraries you should have Manage Libraries button. If you press that, it should pop up the Library Manager, which will update the list of libraries that Arduino supports. And once that is done, just search for MQTT, and then you have to choose the Adafruit. I'm just gonna do Adafruit MQTT. That should give me this library. Since it's installed, I'm gonna close this, go to examples, and then head down there and try to find the Adafruit MQTT ESP3266 library or the example. I'll open this, I'll close the previous one, which I don't need anymore. Right now this is example file, and it works pretty much okay for ESP8266. We'll probably have to just make a few line of changes to make it work with ESP32. Now since everything is installed for ESP32, we don't need this library, and we just need Wi-Fi.h, which is provided to ESP32. This is pretty much straightforward. Everything is defined. First, it asks us for SSID, so I'm gonna give it my home SSID, which is FANO_ARA, and then the password for Wi-Fi, and then it has io.adafruit.com, and then the port, and then here you'll see that it asks for username and then IO key. So you can get that here. Go to io.adafruit.com, you should see this screen, and then I'm gonna just click on sign in. Since I was already signed in, it will redirect me to this page of dashboard, but I don't need this at the moment. So I'm gonna just jump to feeds, which is what we need, and press on view all. Now this is the feed that gets the data from IFTT, and then it sends back to ESP32 chip that we have. So let's create a new feed saying smart light, and then create the smart light feed. And now you should see this feed, which doesn't have any data because there is no one sending it or receiving it from. So once that is done, I think Adafruit's pretty much job is done, except the my key section. So if you head over to this section, you should see username and active key, which is what we need under this example. So I'm just gonna copy username and paste it under here, and then I'm gonna copy the key and paste it under here. And once that is done, I should be able to save it. I'm gonna save it as on the desktop. I'm gonna save it as test_ESP32_MQTT. And once that is done, I'm gonna upload. And it's going to connect to the board, and then it's gonna upload the firmware that we just compiled for this file. And then if you click on the serial monitor plotter, you should be able to see sending protocol val OK 0. That means we have connected successfully. You should see all the logs again. which says connecting to that Wi-Fi. Wi-Fi is connected, the IP address that we connected to that Wi-Fi, and then it's trying to connect to MQTT, which is successful, and then it just sends to photocell, which is example. We don't need this, so we'll remove that in a second. We'll just get rid of this. We have on off field, and now since we renamed that our field to smart light. Now another thing is that you will find all those feeds here. So whenever you want to interact with any feeds, you just have to use the URL name and should not use any spaces under it. So I'm going to copy that URL feed and then paste it here, and now you should be able to get any of the data that happens on this feed. Based on the subscription, it will do something. So if we have subscription based on on-off button, which is we define, it will say on and then the value of that on-off button feed, and then it will just print it. So now let's upload this corrected code. Let's go back to see what else is remaining for our smart LED to complete. iftt.com, and if I'm hoping that you'll already have the account ready. If not, then just head over to accounts and then create one account for yourself, and then once that is done, you should hopefully see this screen if they don't change anything. And under this section, you can create a simple applet and provide the action. So, and we need action as Google Assistant action. If someone says anything on the phrase, or if someone says and that matches our phrase, then we'll trigger something, trigger the IFTT to do something. And our phrase that we want is turn LED on, and it can be said like turn on the LED, or maybe LED on, and we want the assistant to say back is okay, LED is turned on, and this will create a trigger. And now once this trigger is created, what we want to do is basically send this data to IO feed that we have here, and that will eventually get back to Arduino. And so let's add that into this section. You can search is Adafruit, or you can just see that here. Once you click on the Adafruit, you should see send data to Adafruit. You can click on that, and then you should see all the feed names that you have registered under Adafruit account. And this should ask you to authorize the account that you have with Adafruit, and once that authorization is done, you should see all the feed name here. Mine is directly showing here, but yours will ask you to authorize. And once that authorization is done, you should be able to see smart light under here, and then say on here, which will be sent to Arduino. And then hit on create action, and then let's confirm if that's what we want. If someone says simple phrase on the phone, then what we want to do is send data to Adafruit IO. That is what we want. So let's confirm that, and now it says connected, so we should be able to receive that under here. And now I'm gonna do a simple test. Turn LED on. Okay, it says got on, but it hasn't started the LED yet, because we need to do something with that on. And we're gonna head back over to the code that we just developed. We're gonna define the LED pin that we want to interact with, which is pin number 2. LED 2, and then we'll use this constant to start LED and say that it's output LED. We can copy this example from just recent one that we used of Blink, which talks about pin mode LED built in, and then we have to set up the LED pin, and then write the high when we get the input as high. So right now we get on off, but get a string value on this on off button, and we can just compare the string to some specific string that we already know we'll get. And then if that happens, then we'll just update the LED. To do that, let's head over to Arduino's string API and see what we get in the string. So if you go to strings Arduino, this references documentation, you should be able to see this. and it does have index of. I'm going to use this, so let's use index of. And since it didn't do anything, let's do something when we get this output from on off button. We want to check, we want to first convert this on off button dot last read into string, and to do that we'll use string API and say message is equal to string, and then check the API if this is correct, and pass the same character buffer to the string. And this, what this will do is convert the character array into message string, so we can do some stuff on it. We will check if it has the index of on string, and if it's not equal to -1, so -1. What this means is basically we are checking for presence of on inside of this message, and if there is presence of on, then we'll just trigger digital write on LED built-in. So let's copy that and come back to the LED built-in and then paste it here and then put it on high. And if it's not on, then it obviously has to be false. So let's copy this and turn the LED off. Let's change it to low. This needs to be capitalized, and then upload the program. Now once the upload is done, let's go back to serial monitor and see if what is happening on this MQTT serial or ESP32. I'm gonna reset this to see everything happens correctly. After reset, it connects successfully to Wi-Fi and it's waiting something to happen from MQTT or Adafruit. Now I'm gonna go back to my phone again and say turn LED on. Turn LED on. And as you can see, the LED is triggered on my ESP32. Turn LED off. Turn off LED. Now, since the Google is saying it could not understood, I think I know the problem. It's because I haven't added the turn LED off trigger or applet in here, so I'm gonna do that just now. If you go back to AFTT and create, you should see the screen. Under if this, I'm going to do Google Assistant, and under Google Assistant you should be able to see simple phrase, and under simple phrase I'm gonna do turn LED off. Another way to say it is turn off the LED and turn off LED, and then that should say okay, LED is turned off. Create a trigger. This should do that, and then for a action we should have a Adafruit, and we need to pass the data as to smart light, and then data would be off, and then just create action. And this is done. Let's hit continue, and then once this is correct, we can finish on the IFTT. And once this is done, give it a second and you can head back to the phone and try turn LED off. Turn off LED, and now you should see on your ESP32 that the LED indeed gets turned off. Thank you guys for listening onto this tutorial. Let me know in the comment box how you really liked it, and if you want me to have anything else, please subscribe if you liked it and share. Thank you.